Hello ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be going over the intricacies of single and double displacement reactions. So make sure you follow along with your notes and you fill in everything as you see. So before, when we were doing predicting products of reactions, I said that we weren't going to worry about the states of matter on the product side of single and double displacement reactions. Now the reason why is because we needed to know a little bit more about the intricacies of single and double displacement reactions. So here's the general idea. When you have a single or double displacement reaction, normally you're going to be making a precipitate. So a precipitate is a solid that forms in a chemical reaction as a product of a chemical reaction. So the only real product type reactions that we've talked about that form these solid substances are double and single displacement reactions. So at least single and double displacement reactions have the ability to make a precipitate. Now, how can you tell if a precipitate is being made or if it's not being made? Well, in a double displacement reaction, it's nice and easy. We can use our solubility chart to tell if something is insoluble or if everything is soluble. So using our solubility chart, which you should have, we can just easily find our cation and anion and see on our list, is that going to be a solid substance or is that going to make an aqueous substance? Okay, and so if it is solid, then that means that I made a precipitate. On the other hand, if all of the products are soluble, so instead if everything is aqueous, then that means that no reaction actually happened. So get out your solubility charts because we're going to predict and see whether or not precipitates form in the following reactions. Alright, so we have a nice simple reaction here. We have copper 2 chloride mixing with silver nitrate, and these are our products. And so where did we get these products from? Well, remember, we can predict the products of reactions. So this is where our products came from. Now, I need to know whether the products are soluble or insoluble in water. So inside of those parentheses, I'm either going to be writing down an AQ or an S, depending on what my solubility chart says. So take a look at your solubility chart. Copper nitrate. So copper 2 nitrate is aqueous in a solution. And then I'll take a look at silver chloride. Silver chloride is a solid in that solution. So right here, I have a precipitate which formed, which means that if I were to add copper 2 chloride and silver nitrate together, I would see a solid forming by mixing those together. I would see silver chloride coming out of the solution, and that is my precipitate. Now let's move on to the next one. Again, I have lithium carbonate and I have barium chloride. All right, so again, I need to figure out whether my products on the other side are going to be soluble or insoluble. So are they going to form a solid or are they going to be aqueous? So by looking at my chart, I can see that lithium chloride is aqueous and barium carbonate is a solid. So that means that if I were to add my two reactants together, I would end up getting barium carbonate as a solid forming in my solution. That's how we use our solubility chart with double displacement reactions. Now last but not least, I have my sodium chloride and lithium nitrate, and I'm mixing those together. So I need to see whether or not I have aqueous solutions or solids on the opposite side. So take a look. I have sodium nitrate, that is aqueous. I have lithium chloride, that is also aqueous. So what does that mean? If I mixed these two things together, I get no reaction. And that's very important because I have a nice little equation that I wrote down, but nothing would happen if I were to mix them together. So this chemical reaction, this last one here, is not a possible chemical reaction. Nothing actually happens as a result. What about single displacement reactions? Now, whenever I have a single displacement reaction, I get a product that is either a metal or it's going to be hydrogen gas. Okay? Not every metal, though, is allowed to replace another in a reaction. In fact, there is a list which we call the activity series. So if you take a look in Google Classroom, there is an activity series, and we can use it as a source to figure out whether or not a metal can replace another. Now, how do we use the activity series? The rule is a metal that is higher on the list can replace any metal that is lower on the list. If a metal lower, though, tries to replace a metal that's higher, then we get no reaction. So in other words, pretend that I have a list of, different metals and stuff right here. So I'm allowed to do the following. If a metal higher wants to replace a metal lower, that is allowed, that is okay. But if the opposite tries to happen, if a metal lower on the list tries to replace a metal higher on the list, that is forbidden. That means no reaction will occur. So take out your activity series, or print it out, or take a look at it in another tab, because we're going to need to use it for the next bit. In case you don't have one, here is a look at what the activity series looks like. Now, the only thing on here that is not a metal is hydrogen. Hydrogen's right here, because sometimes H2 gas is made in a reaction, and so it's extremely important to kind of include that for reasons that we'll talk about in second semester. But again, anytime we have something higher on the list, it can replace something lower on the list, but you can't go the opposite. So you can't do something like this, but you can do something like this. So let's take a look at these. Do each of these single displacement reactions actually form a precipitate or not? So again, here is a possible single displacement reaction. All right, so zinc is trying to replace copper, magnesium is trying to replace sodium, iron is trying to replace silver in each one of those cases. So take a look at your activity series. Can zinc replace copper? Zinc is higher, copper is lower, so this is a correct reaction. This is something that can actually happen, all right? So this guy is allowed to happen. Next up, I've got magnesium trying to replace sodium. So here's the thing. Magnesium is lower on the list, sodium is higher on the list. So this reaction is forbidden. No reaction would happen. I could take a solution of salt water and put a strip of magnesium in it, and nothing would happen as a result. Okay? No reaction. It is forbidden. Next up, I have iron and I have silver oxide. So take a look. Iron is higher, silver is lower, so this reaction is allowed. If I did this, I would see silver metal coming out of my solution. Okay? So, again, if you have any questions, make sure you ask tomorrow. Otherwise, that's it.